All right, guys, I want you to take a look at this. We're going to be doing some notes on a little level of equation skills that we talked about. This is a super important part of equations, but let me just tell you what this tree map is going to be. We're going to call it number of solutions. Now, number of solutions just basically means number of answers. And there's going to be 3 branches. All right. And there's your 3 branches. Okay. Now, your first branch over here, I want you to realize it's going to be called, let's do one solution in the middle. And this is what we've been doing, where there's one answer. Okay. So let me just give you an example. If I said 5x plus 10 equals 90, all right, then you would solve your problem. You would subtract 10, bring this down, you would get 5 into 80, right? Then it would be what? X equals, that 16? And you would have this, and actually I'm going to put in front of this x, isn't there a 1x in front of here? All right. Now imagine this is, let's just zoom in here so you get caught up. This is what we've been doing. We've gotten x down, 1x, right? This is a 1x. I'm making that very clear because I'm going to tell you in a second when we start doing stuff with the x, you're going to find out what's happening. But when this x is here by itself, this is one answer. There's only one possible answer that could work for this problem, okay? There's only one possible answer that this would work for. So let's go ahead and get into the next one. Now I'm going to tell you, this is crazy, but actually, no, I'm going to tell you right now, it's going to be 2x. Actually, hold up, my bad. On here, it's going to be no solution. All right, and then let me move this down a little bit. So this one will be 2x plus 4 equals 2x plus 6. All right, and the first thing I want you to notice, what do you notice about this equation? And if you notice right away, there's a 2x on both sides. So when I do this next step, it's going to be kind of weird, right? Because what's going to happen? I'm going to go subtract 2x, right? Letters to the left. This cancels out. And this is what I want you to write today. I mean, basically, this whole thing cancels out. And in the book, it would write, this would cancel out too, and they would bring down the 4 and the 6. And they would, in the book, it would say, does 4 equal 6? And you would say no, so it's no solution. But let me just tell you how I do it, okay? We brought the letter to the left, we cancel this out, but I call this a 0x. I know that looks weird, okay? But just stay with me. I'm going to bring it into my equation, okay? Now that you have this here, subtract 4. Now, is this a true statement? 0 times x equals 2. 0 times x. Is there anything times 0 that would equal 2? So this becomes no answer. There's no answer for this. There's no answer for this at all. There's nothing you can multiply and plug in for x that would make both of these sides of the equation equal each other. All right? Now we've done one solution. We've done no solution. Okay? Now we're going to jump into something called infinite solutions. And just take a look at this. Notice how it's almost very similar looking. And now look what I'm going to do on this side. Infinite solution. Okay? Now 2x plus 4 equals 2 times x plus 2. All right? Now let's go ahead and solve it. What's your first step? Distribute. 2x plus 4 equals, wait a minute, 2x plus 4 equals 2x plus 4? That's the same on both sides. When you see the same expression on both sides, the same junk on both sides of the equal sign, you know you have an infinite solution. But let's just go ahead and solve this. All right, we would go letters to the left, cancel this out. Again, I want you to make that 0x plus 4 equals 4. Then I'm going to subtract 4, and I'm going to get 0x equals 0. Now let's think about this answer. 0x equals 0. What times 0 equals 0? What if I said x was 10? Would this be true? Yep, 10 times 0 equals 0. What if I said x was 100? What's 100 times 0? 0. What if x was negative 422? What's negative 422 times 0? 0. So guess what? Every answer in the world would work in this one. And when I see this problem, when I see double zeros like this is what I kind of like to do too. I would have a poster of this on my wall so you could see it. And this is my infinity sign, all right? So make sure you understand that when they're both the same on both sides, so they're both the same here, that's what I should do. This one doesn't look so similar to this until you do the math here. But when they're both the same, you know it's infinite. Now on this side, how do you know when it's no solution? When your variables are the same on both sides, but your constants are not. Okay? So we're going to do a couple problems like this so we can get a good sense of what in the world's going on. All right? So actually, let me just go ahead and leave it like this. Hold on. If anyone needs to get caught up, you could go ahead and, I think, pause the video. All right, we're going to move on. Next problem. Solve this equation. All right, go ahead and try to solve this problem for me and give me an answer in the EDPUZZLE. All right, if you solved it, you got 5x plus 20 plus 7x equals 7x plus 21. All right. Oops, this is plus 2x. There we go. My bad. That's a 2. All right, what's the next step in solving this equation? Don't I have to combine like terms? And then now, looking at this equation, can't you be a detective and see, all right, same variables, but different constants, all right? So I know if I look at my tree map which answer this is going to be, but I'm going to go ahead and finish it off anyways. I'm going to get 0x plus 20 equals 21. Subtract 21. Oops, I subtract 20. I'm going to get 0x equals 1. What times 0 is ever going to equal 1? Nothing. Never. Never going to work. All right? All right, here, let me give you another one. All right, go ahead and solve this one for me. First step to handle the distributive property, right? On both sides, handle your distributive property. So I'm just going to rewrite this. This is going to be 2x plus 2x plus 10. This is going to be 3x plus 12. All right. Then, what am I going to do? I'm going to go ahead and combine my like terms. 4x plus 10. Do I see same stuff on both sides? Nope. So this is just a simple equation you had to solve. Letters to the left. This is just how I handle it. You could go to the right too if you wanted to. All right. Then from there, I'm going to subtract 12. Negative 1x equals negative 2. Divide negative 1. Negative 2 over negative 1 equals positive 2. Okay? If you were ever wondering if this actually did make sense, what if I plugged in 2 here, 2 here, and 2 here? So 2 in here would be 2 plus 4 is 6 times 3. That would be 18. 2 times 2 here is 4. 2 plus 5 is 7 times 2 is 14. Does 18 equal 4 plus 14? So it all checks out. You can always check your answers by plugging in your 2's in here. All right? You could totally do it that way too. All right, let's do one more. So for this one, all right, go ahead and solve this one for me. First step, distribute property. Okay. 3x plus 15 plus 2x equals 5x plus 15. Then combine like terms. 5x plus 15 equals 5x plus 15. I'm okay at this point if you wanted to stop. Because this is another thing I would put on the wall. Notice how both sides of your equation are exactly the same. Okay? That means now that your answer is infinite solutions. If you wanted to finish it, you know that this would have canceled out over here. All right, this would have canceled out over here. And you would have gotten infinite. Every answer in the world, every integer, every number would work for this one. Okay? Hopefully you have a good sense of infinite solutions, no solutions, and one solution. Okay? Remember, if this was asking a question, this one we just did, where we got x is 2, that's one solution. Okay? That's just one answer. All right. Good job, guys. Make sure you have these notes and that puzzle done by 2 p.m.